Hi everyone, today is March 19th. It is Thursday, and we are going to continue with Unit 1, Section 121. All right, so our warm-up is on page 53. We're going to start looking at populations versus samples. And if you read the warm-up, it's kind of a pretty straightforward math problem. As I've been doing, here's the blank slide and answers on the next slide. Okay, so for this first one, okay, this might be a little tricky. I need you guys to kind of think about it. How many possible different combinations can we get of two essays? And the answer is 15 because I could do 100 with 95, 100 with 90, 100 with 85, 100 with 80, and then 100 with 60. Okay, but then I could do maybe 95 with 90, 95 with 85, 95 with 80, 95 with 60. So if I kind of continue doing this now, 90 with 85, 90 with 80, 90 with the 60, okay, if I keep doing this, this is how I got my 15 combinations. And lastly, the 80 paired up with the 60. So if you kind of follow through, count up all the little lines I made, it gives us 15. All right. Remember, the average is the same thing as the mean. So I took my two lowest scores, added them up, divided by 2. Likewise, in number 3, I took my two highest scores, divided it by 2. Okay. And then instead of looking at 2 scores, I looked at 4. Hopefully you did well with the warm-up. All right, so here is our learning target. So hopefully by the end of the video, you can accomplish the following. Okay. All right, so this takes us to our vocab. So I do want to point out a few things. Okay. So population is all of the people or subjects of interest that the researcher is investigating. Okay. Now, with the population, when I want to do some sort of mathematical computation, we call it a parameter. So the summary data of a population. Sometimes that calculation might be calculating the mean, the standard deviation, and so forth. Okay, a smaller subset of the population is called the sample. So a sample is a subset of a population. Data is collected from samples. Okay, usually the sample should not exceed 10% of the population, but you definitely want a sample size greater than 30. Okay, now any mathematical computation that needs to occur for the sample, that is called the statistic. Okay, so it's going to be basically the same computation for the population, but for a population, that calculation is referenced to be the parameter. And for a sample, we call it the statistic. So it's kind of nice. Population parameter begins with P, sample and statistic begins with P. So I wanted to really highlight those vocab terms because that's really what we're going to apply in today's lesson. Here are the rest of the terms. Something new, chance variation, measuring. It's a measurement showing how precisely a sample reflects the population. All right. So example 1 can be found on page 55. I'll let you guys kind of read through. Here are the questions, some things I want you to kind of think about. Maybe pause the video, give yourselves a minute or two to address these questions. And here are the answers. All right, so the parameter. So the parameter corresponds with the population. So the population is basically all of the rolls that are possible on a six-sided die. So typically the population is you need to kind of think outside of the box. Given the context, what would be the population for this scenario? So even though this example just talks about Adam and how he rolled the dice 4 times and he got the following outcomes, that is going to be our sample. The population is that Adam could have kept rolling the die and he could have gotten a 1 or a 6. Okay. And then if you reread the problem, they are asking for the mean. So the parameter is going to be calculating the mean for all of the rolls on a six-sided die. The sample, okay, is again the subset of the population. The sample consists of the 4 rolls that Adam got. What is the statistic? The statistic is again calculating the mean, just like it was for the parameter, but it's calculating the mean of only the 4 rolls. So there is going to be a little bit of repetition here. I hope you kind of see that throughout the lesson today. And then they wanted us to actually calculate it for the 4 rolls. So the mean or the average is 4 25/100. All right, next example. Okay, give yourself some time to read the problem, process the chart. So notice we're talking about a doctor. Okay, wants to look at his patient's high glucose levels. This is only the results of 25 patients. And he wants to calculate a percentage. Again, here are the questions. It says identify the population parameter. So these correspond together. And then the sample and the statistic. Alrighty. So let's see how you did. The population is all of the patients that this doctor sees. Hopefully this doctor sees more than just 25 patients. Okay, the parameter would be the percent of all of the patients with a fasting glucose level greater than 100 milligrams per deciliter. Okay, now the sample is going to be just the 25 patients that are recorded here on this table. The statistic is going to be the percentage of the patients that have a fasting glucose level that is greater than the 100 milligrams per deciliter. But again, it is only for these 25 patients. And then here is the actual calculation for our sample. So there's only 7 out of the 25, so it looks like 28% meet that higher glucose level. All right, example 3. So it looks like we've collected some data, okay, from 1971 to 2000. It's average total year precipitation for each of the following states listed below. We have a sample of 10 states. And basically, we want to use this sample to estimate the total rainfall in all 50 states over a 30-year period. So that's the math that we're going to eventually calculate. And just like the previous problem, I've kind of broken down this problem into these components. These are the components that we need to identify. Okay, give yourselves about a minute or two. What would you think the population should consist of? What would be the parameter for the population? What is our sample? What is the statistic for the sample? And then let's do the calculation. So the population is all 50 states, not just the 10 that's being recorded on this table. The parameter would be calculating the rainfall from 1971 to 2000 for all 50 states. The sample is the 10 states that are listed in the table. The statistic that corresponds again with the sample is calculating the average yearly precipitation for only these 10 randomly selected states. All right, and let's discuss the calculation. I want to make sure this all makes sense to you guys. All right, so the average for the 10 states, basically I took these values and I added them all up. Okay, so I added those up and that's how I got this answer. I'm going to divide it by 10 because there's 10 states. So basically we get 32 6/100 of an inch per state. But notice this is only for 1 year. Okay, so first of all, it's per state. So let's times this by 50 so we can see how much we get in 1 year for all 50 states. Okay, but now we need to take this into consideration over 30 years. So let's take our previous answer, multiply by 30, and that's how I get 48,090 inches. Okay, and that's my final answer. So the estimated total rainfall in all 50 states for the 30-year period is 48,090 inches. Just something to kind of think about. Are there any flaws with this method? For instance, are all 50 states going to get the same amount of rain per year? Right? Some places it rains a lot more than other places. So, this is again just kind of an estimation, but going back to our stats units, these are just things you want to question. All right, so I want to show you, okay, these are the steps as to how your calculator can actually calculate the mean, the average, or standard deviation. So you would enter your data in your stat menu in your Lsn1 or Lsn2 list. And then by basically pushing stat, highlighting calc, and hitting option 1 var stat, and pushing enter, it will calculate the mean and standard deviation for you. Okay, but notice, okay, you're going to get a lot of data. Make sure you're looking at the proper notation. So the one that has an X bar above it, that is your mean or your average. Okay, and this one is called lowercase sigma, and this will give you the standard deviation for the population. And then just a quick little shortcut, if your Lsn1 is not displayed, then push second, push the 1, and enter, and Lsn1 will reappear. Okay. All right, so I'm going to pause this video and I'm going to have a second part to this video. So thank you for watching part 1 and hopefully you will watch part 2 very shortly.